partial fractions. So your test on Tuesday is going to be up to and including section 7.4. Anything else that we might have been doing, I'll just push that forward to the next test. I'm also going to move the due date. Since Monday's a holiday, I'll move the homework till Monday midnight. So it gives you a little bit more time if you need it. Hopefully you don't, to get your homework finished.
I approve of that decision.
Okay. So let's, whoops, I'm in the wrong section, sorry. I'm just looking for some questions that we can go over that we haven't covered already. Just take me a few moments to load up the homework so I know what we have and haven't done yet. Okay, so I think what I should do probably, now I'm thinking about it, is to do another example where you have to do the general algebraic method, okay? So this one is similar to question 9. Just moving some windows around, other chasters around. Darn it, I need another TV, I need a third monitor. Here we go. So, we're going to find the integral from, we'll just do a general integral, that's fine. And we'll do it 2x plus 1 over x take away to x squared plus 4 dx. Okay. Can I use the linear shortcut method on this, or do I need to use the general algebraic method? Because if you get a question, you have to know that, right? You have to know what methods works. Which method will I use to do this partial fraction question?
The general algebraic.
Right, correct. What was the clue? What could you see in here that told you to go that route?
The x squared plus 4 on the bottom.
Right. Isn't the rule if there's an x squared anywhere, won't you also do it if it was an x squared x plus 4? There's a slightly different looking version. Wouldn't that be the clue that you must do the general algebraic method? Okay, so that means I need to split this guy up. And he's going to be an a over x take away 2. And just to remind each other, what goes above the x squared plus 4? What goes here?
bx plus c.
Correct. Isn't the rule that when it's an x squared plus 4, you have so many x's plus a letter? So in this case, b and c are the next two letters. So bx adds c. So far, so good. Now, if I'd planned ahead, which I didn't, I would have written this line away over here. So you don't need to write this. This is me just making myself some room. What I now need to do is put these fractions back together again. And they need to share the same common denominator, which is this guy. So the a over x minus 2 is going to be multiplied by the piece it doesn't have. And the x squared plus 4 is going to be multiplied by the piece it doesn't have. Now, to save one line of working, won't the top line, which in this case is 2x plus 1, equal the top line of the right-hand side? And do you notice that you do not foil anything out, right? You just leave it alone. That seemed pretty much yesterday. Great. Now, from this point onwards, don't we have to start choosing x's? And not only do you have to choose x's, don't you very often have to choose them in a particular order as well? So that just adds to the problem. What would be a good choice of X for this one? Remind yourself, the goal is to have just one letter left alive.
2.
And if you made X equals 2, won't you destroy all of this as 0? Do you see how that's how you make up the mind, right? You look at what makes this 0. So if you plug in 2 here, what you're going to get? 2 lots of 2 plus 1, which is 5. 2 squared plus 4, that's going to be 8. So you're going to get that guy. And this gives you A is 5/8. And then what you do is you return back to here and you write it down again, but this time replace the A by 5/8. And then you are going to have to do choose an X guy. Now, same goal as before. You want to pick a value of X that leaves behind just one variable. There are only 2 to find now, B and C. So you got to pick an X that makes either the B left over or the C left over. So what are you going to choose this time?
I would go with 0.
I would. Wouldn't that kill off the B? So 2 zeros plus 1 get you 1. 5/8, nothing plus 4. 0, that's just 0 then. Plus C. And 0, that's -2. So I get 1 equals, multiply that by that and you get 5/2 minus 2C. Oh, not very nice. If you subtract 5/2 from both sides, you're left with -1/2. If you divide both sides by -2, you get +1/4. And so we now know what C is. So you go to this line and rewrite it, but turn that C into this fella.
Isn't 1 minus 5/2 -3/2?
Did you all catch that deliberate mistake? Yes, it is -3/2 because 1 is only 2/2 and 2 take away 5 is 3. And 2 negatives cancel later on. So we got 3/4, which takes us to 2x plus 1 again. 5/8 of this fella plus bx add c of x take away 2. And really, you only need to do it one more time. And we just choose an x, any x you like, as long as it doesn't kill that b, either directly or indirectly. Theoretically, then, can I choose an infinite number of choices? 4,111? But I'm not picking that. See if anybody's a mind reader. What am I going to choose? Yeah, you are so good at reading my mind. Do you know why I picked 1?
It's easy.
It's easy. That's the only reason. Pick what's easy. I would. And if you want to give yourself a challenge, pick 4,011. It'll still give you the same answer. As unlikely as that seems, it will. So 2 lots of 1 plus 1 is 3. 5/8, 1 squared plus 1 is 5. B is 1. So I get this, and that gets me -1. So let's see what we have. 3 is 25/8. Well, -1 times that gives me this. Oh, that gets me 6/8, so I now have 19/8. I wish I'd thought this one through. That's 24, take away 19 is going to leave me with 5/8. So that makes B -5/8. So you take all of what we've done, and it's took a long time to get here. All we've really successfully managed to do right now is to split this into its partial fractions. So we have the original question, and it's equal to A, which was 5/8. So 5/8 over x minus 2. Then we did a B. We did a C first, okay. And then a B, so what was B? -5/8. And a C was +3/4 over x squared plus 4 dx. Now what you should do here is split them into 3 distinct integrals. -5/8 of this guy, -5/8 of this guy, and 3/4 of this guy. This fella here is a natural log. This guy here is a bit messy. Forget about the 3/4 for a minute. Isn't a 1 over x squared plus 4 that special inverse tan guy? Right? And it's a half inverse tan of x over 2, right? That's what that guy would get you. Now 3/4 and a half is why that's 3/8 inverse tan x over 2. Are you happy about where that came from? What on earth am I going to do about this fella here? How am I going to find the integral of this guy?
Substitution.
I think I heard it. You sub? So I'm going to do it over here as a piece of, like working on the side. Would you agree that x squared plus 4 would be the good use of? If you differentiate it with respect to x, you do the crossover, and then you isolate the dx. So I'm going to get 5/8x over u times 1 over 2x du. Oh, that's really ugly, but that cancels with that, and now you get 5/16. And I'm going to bring the 5/16 outside the square root. And that gets me 5/16 natural log of u, which gives me the answer. And now we can put it in there because it's a subtraction. Are we good? Took about 15 minutes. It's a long question. So what's left? Well, there are only 2 more questions to go. Is it 2? Yeah. And both these questions say make a substitution first, and then you can deal with the partial fractions later. So this is question 10, or at least a version of it. Actually, it's not a version of it. It is question 10. I don't think they have changed it in any way. Sometimes, and this is one of those sometimes, you have to trust the math. And what I mean by that is that you're told it's a U-sub, so you've got to trust that it is a U-sub. And then you've got to say, well, who is the only U-sub in town here that I would probably want to use? There's not many choices. U sub equals X is pointless. It never ever does anything, right? U sub equals X minus 1 might work, and very often it should work, but not this time. What I mean then is that if all else fails, isn't the only thing left have to be the U sub, right? So U equals X fails. U equals X minus 1 looks like it's got promise, but trust me, it fails, right? You end up with an ugly answer. It can't go anywhere. So I'm going to have to do this guy, which means that I'm going to have to call this guy X minus 1 to the half. And now I'm going to differentiate it. And won't that be multiply by the power and reduce the power by 1? Technically times 1, but that doesn't really matter. And I'm not going to do any weird crossovers yet. I'm going to make this thing look pretty before I do anything else to it. So this is the derivative in its style point form. Now I'll do the crossover. Oh, we've already got dx. So what do I have? I have 1 over x, the square root of x minus 1, times dx, which ends up being this guy. And here's a U sub that we've probably never seen before. You ever seen one that does that? And what do I have left? Oh dear. I have an ortho x. Right? I got a little x left over. You might give up. Don't give up. Trust the math. I got a U sub. If I work on that U sub, shouldn't I be able to find out what x is in terms of U? Okay. What is the first thing I should do to both sides to get x?
Square. Square both.
So, yeah, square. Wouldn't I then add 1 to both sides? Which means this guy is that. I just realized. I didn't realize it until I got here. I don't even need to do partial fractions in this one. Agreed? Can't you integrate that right away without any extra work? What do you get if you integrate 2 over u squared plus 1? The same thing you'd have got if it was 2 over x squared plus 1. Right? What would you get?
2 inverse tangent.
Have you? Agreed? Well, I guess plus c, which then becomes 2 inverse tan of the square root of x minus 1 plus c. And what was the ugliest looking question in the world actually ended up being one of the quickest. Are we good with that? That's actually question 10. It's not a version of 10, it is 10. On the other hand, this is a version of 11, so there are different examples of it. It's another one, make a substitution first, and then do partial fractions. I do know that this one does give you a partial fraction, so this is going to be, this one's going to be a bit longer because of that. Oh, we have problems here. We're told it's a U-sub. We're told use substitution. It's a U-sub. And there are tons of possibilities, but only one actually works. And you might try, version A and it fails. And then you try another version B and it fails. But if you keep hitting it, you will eventually get one that works. Anybody want to give me a gut feeling for what they think it might be? And I'll say yes or no, depending on what you tell me.
E to the 2x plus 1?
Could work, not in this case. Nothing wrong with that. It's a good guess. I mean, it makes sense, right? Couldn't a U sub be one of the brackets? And I can imagine situations where that would have been exactly the right thing to do, but not this one. Think small. There's a clue. Don't think big. Think small. Little tiny thing.
Is it just e to the x?
It is. Well, I'll have to prove it to you by showing it working, right? Because you're going to guess in a different world, oh, I'll try this. It doesn't work. I'll try that. Oh, that does work. If you differentiate with respect to x, I mean, it's one of the nicest looking, one of my favorites, as you know, things to work with. Because it's very hard for me to screw up e to the x, isn't it? Don't matter if I differentiate it or integrate it or do anything, it tends to be easy to deal with. Well, let's see what we got here. I'm going to play safe here, even although I know I don't need to. If you've got an unusual U-sub, it's probably a good idea to do nothing to this right away. Just leave it alone for a minute and only do one thing. Right? The dx. Now, can you see cancel, cancel? And now we are looking at a really ugly orphan. All these x's left over. Now, don't these guys need to become u's? Okay, what do you think e to the x take away 2 becomes if you convert it to u's? That's u. So what will e to the x take away 2 become?
Just u minus 2.
Great. Now don't let this one freak you out. E to the 2x. E to the x is u. What will e to the 2x be?
So e to the 2u?
Yeah.
Oh, yeah.
E to the 2x. You wouldn't normally write it this way, but isn't it that guy? Now, can you see that what you've now got is a classic partial fraction question? Agreed? The only major difference is that we're using u's instead of x's, but I don't think that's a really a deal breaker. So I'll do it over here. It's not unlike the one we did at the start of today. Isn't it going to be a over u minus 1 and b over, oops, almost did it wrong there. Are you happy about the partial fraction split, the a, the b, u plus c? We're good with that? Okay. What am I going to multiply each of these fractions by to get them back together again? So they both have to share this common denominator. So what will this guy here, the one with u minus 1 in the bottom, be multiplied by to make it become this guy?
U squared plus 1. And also, I think that's supposed to be a U minus 2.
Ooh, well cut. What goes on the second fraction then? What does this one get to become that?
U minus 2.
Great. Now, the tops are going to equal. And we got that. Okay, I'm going to put you in the spot, guys. I want you to find A, B, and C. That's all you need to do right now. Find A, B, and C. And I'm giving you 4 minutes. And for those who need a little jump start, I'll even tell you who the first U is. Choose U equals 2 the first time round. Okay, let's get this show on the road. Well, we said that you're going to choose 2, so let's do that. 1 is still 1. 2 squared plus 1 gives you 5, so that's 5a, but won't all of this basically become 0? So a is 1/5. So I now have 1 equals 1/5 u squared plus 1 plus bu odd c, u take away 2. Okay, who are we going to pick for the u for the second time?
U equals 0?
Yeah. Isn't this almost a carbon copy of the first question today? There's only so many different kind of versions of this that it's not uncommon that you end up doing the same kind of things each time. So 1 is equal to a fifth of nothing plus 1 is a fifth. If that's 0, you get c times -2. So I have 4/5 is -2c. So -2/5 is c. Now you know what my counting in the head's like. Does that look good? I got a thumbs up, great. So we continue by writing down what our new guy is. Well, he's 1/5 u squared plus 1. Add bu minus 2/5 of u take away 2. And
Wait, hold on.
oops. Okay.
Should the one? Oh wait, never mind. No, I got it wrong.
That's okay. You know me, I'd rather you did that than let something I did wrong slide. I think we've already decided, aren't I going to pick one? I don't know if you picked one, but I'm going to pick one for my last due. So 1 is going to be 1 squared plus 1, so that's 2/5. A single b take away 2/5 times a -1. Now, it's going to be a bit messy, but I should be able to handle it. It's going to be -b plus 2/5. So it's going to be 4/5 take away a b. That leaves me -b is this, so b is -1/5. So I hope you got 1/5, -2/5, -1/5. Right. If you got that, things are looking good. So back to the original problem. I mean, it's that long, it's hard to remember what the original problem was, but it was this guy. At least what we've just done was this guy. So we have this fella, and he is a, which is 1/5 over u minus 2. And then we have a b, which is -1/5 u, and a c, which is -2/5, all over u squared plus 1. And I'm going to split that as a 1/5 u minus 2. Take away a 1/5 u squared plus 1. Okay. Take away a 2/5 u squared plus 1. This guy gives me a log. This guy here eventually gives me that. Eventually gives me that. And this guy at the end gives me that. So what could possibly go wrong after you've done all that hard work? Well, what could possibly go wrong is that that's not the answer. That's the answer in terms of u, but wasn't the real question right up at the top here. So you do all the hard work and then you forget to turn it into x's. And that guy is 2x. And now you're right. Okay. If the original question is x's, shouldn't the final answer be e to the x's? Even although we had to do other things to get there, they're only stopping places on the road to our final destination, which is this.
I have a quick question.
Yes.
How did we get the integral of the middle?
The middle one, I did it in my head because I've done so many of these in my
Oh,
life.
but
So
it's
I'll show you how it would have been done without doing it in your head. I would have had to have done a W sub because I'm
Okay.
using the letter. I'll zoom through it quick. You can choose to write this down or not.
Oh, yeah.
You get this guy, you get this, you get a 1 over this. Cancel, cancel. That becomes a 10th. 10th over u. Natural log of u. Oh, I've decided to go. Yeah, I went. I should have went W, shouldn't I?
Okay.
That used to. I mean, it's just, I guess it's the same guy. And that's where the 1/10 log of u squared plus 1 came from. And then it's a negative. And I converted.
Awesome. Thank you.
That's probably the longest question we've done in partial fractions. So, what can go wrong? God, I keep saying that, and you think, well, God, it can't go any wrong yet. There is a convention that is sometimes upheld and sometimes is not. You might find that WebAssign wants an absolute value around that guy. But he won't want it around that guy. And sometimes they want it and sometimes they don't. And it's not always obvious why it's there and why it's not. If you want to know if this can only be positive, you don't need an absolute value. Couldn't e to the x take away 2 be negative, at least for some values of x, in which case you need it? And how do you get the absolute value? Do you know when you click on the box on the right-hand side, there's a little math thing? Look for the symbol that looks like absolute value and click on it. And that's how you get the absolute value symbol. Do you know what I'm talking about? I got nods, so most of you know what I'm talking about. Okay. In a test situation, don't worry about it so much because I'll know what your answer is, whether you put in an absolute value or not. I guess if you wanted to be a lawyer, wouldn't you just stick in every log in every situation regardless, and that way you know your butt's covered, right? So if you really want to be absolutely 100% sure, I guess that would do it as well. Are we good? So everybody should know what's coming up. Let me go over here for a few moments and you can say hi while I'm getting this all set up, so you can get that done. This is what your canvas would look like, or at least if I click on this, it'll probably turn it in. There, that's more what your thing will look like, right? And if I go to course assignment, and we go down to test 3, can you see what's going to be covered in test 3? Starts at average value, finishes at integration. So it's not a big guess, you're going to get 5 questions, right? Seems reasonable, 5 questions. That I will change, even if I forget to change it here, it will be changed in WebAssign, so you'll have midnight Monday to get it done. There are some massively ugly questions. in these, so that's going to be a bit of a challenge for me to find a question where you can do the method in a reasonable time. But I will try my best to, I will make sure that WebAssign, it tells me how long a question should take, because it's given these questions to tons of people, so it knows the average time. So I will make sure that it works in the time skin that you've got. But yeah, these guys are pretty intense. So we'll see how it works. I may actually get you to only do part of a question rather than the whole question. So when you come to do the test, I'll say, I know question 4 says do all of this, but will you just do the first part and stop here? And that may be my way of getting, you know, my expectation is you'll have enough time to do it, right? So I'll see how it works. I'm kind of thinking about that. Everybody should know, I would assume, that all your Zoom lessons are up here. So we're on week 5, which is this one's, and week 6, which is this one's. That will be today's eventually. I'm just randomly going to click this one because I do not know how this works. And oh, it works. So, whoops. So you click on it and you get to see one of our lessons, and you can always scroll to the bit that you were interested in because it was at the end eventually. And oh, isn't that kind of interesting? Isn't that exactly what we're doing today? That's kind of cool. Okay. So, I mean, that is the resource. There are other resources, and I don't know how many of you have taken advantage of them, but I would suggest that you might want to also look at this link here. Because what I have here are other people's ways of doing things. So for instance, if you wanted to do and see an example by someone else of average value of a function, here's someone who goes into it, and you get a different insight into it, and that's always useful, right? So if a topic, especially a topic that's causing you trouble, right? If you're doing fine, you understand it, no biggie, you probably won't need to look at these videos. But if you are having any issues, it's a resource. I also have in these things some homework help. Right? For here, some stuff to do, that's older stuff, but there's the chapter 7 of them will be. There's chapter 7. If I go down here and we click on notes, and there's some notes on integration by parts, basically just a question. Here's some trig integral. So if I click on this and I make it nice and big, can you see here are examples of doing some of the trig stuff that we did? So you might want to look at that. I know a lot of people are going to have trouble, I probably shouldn't have done it that way, are going to have trouble with the triangle ones. I'm trying to think of a better name for it, but you know the ones that come after that, which I call X subs. If I click on this guy and zoom in on him, here is who you pick. Here's a worked example. Here's another worked example. Here's another one. You can't get enough practice, right, at ugly ones, right? So hopefully somewhere in there, you might have forgotten about all the stuff that we have that I've put together for you. And hey, time is beating me. Okay, you're not allowed to have a nice weekend because you're studying for this test, right? You can have 2 hours on Valentine's Day with your partner, and that's it. The rest of the weekend has to be absolutely miserable because you're going to be studying really hard to get really good grades. I don't think I'm selling that well, am I? I could have probably tried to sell it a little bit better, but it's too late now. Okay, bye-bye, guys. I'll hang about. You tell me when you have issues.
Thank you. Bye.
Okay.
I have a homework question.
Okay, you can start. What one have you got, Bathsheba?
All right. So it's trig substitution. So I did the process and then I'm trying to integrate just secant theta. And I,
Oh, okay. Secant theta is a special guy which you just happen to know or not.
oh,
So I'm going to show you that special guy. You're just meant to know that he's a natural log of secant plus tan.
oh, okay.
It's, you know, these, you're just meant to know secant squared is this, and you're just meant to know that secant tan is that. It's one of those standard integrals that you're meant to know. If you come across something like, cosecant x on its own, right? That would be a standard integral. What you would then do is you just go online and say integral of cosecant x and write down what they tell you is.
Okay.
Okay.
All right. Sounds good. I was just stuck. I didn't know. All
Right.
right.
So the natural log of secant plus tan. They'll probably have an absolute value around it, knowing web sign, but that's better.
Okay. Awesome. Thanks very much.
Well, that was a really quick question, which is good. What we got next? Anybody?
I had a clarifying question. So
Mm-hmm.
when we did the trig substitution, we went like all the way through and then went back up to make everything in terms of x, and
Correct.
then used, like, if it was a definite integral, then we used like the x values that it gave us.
Yes.
But then on one of the WebAssign problems,
Uh-huh.
it made us convert the x's into like the theta values for the integral, and it wouldn't
Ooh,
work.
I wouldn't do it that way.
Okay.
Did it make you do that because it was one
Yeah.
of those tutorial questions?
Yeah, it made us do it just because
Oh, I
I
don't
tried-
like that. I do not like that method. It is ugly.
yeah, because I tried going all the way up and using the x, but
Yeah.
then it said I was wrong. So then I watched like the example video, and they did it where they used theta, and then it worked.
Just shoot me a note. Tell me what the question is. I'll give you the point. Did you get the right
Oh,
answer? If you
Yeah,
avoided
no, I got the right answer. I was just
Okay, so you're
confused.
good. Yeah, I do not suggest that you do that technique. I mean, sometimes it works out nice if the numbers are, if the numbers like 0 and pi,
Yeah,
it works out fine. But if the numbers are like 1 and 4, it is really ugly.
yeah.
And I don't like that method because of that.
Okay, and then just like one more, on one of the homework questions, this is one that I got wrong. It
Uh-huh.
was, what was I asking? I think it was, here, wait, I have to check the question again. So if someone else has something, then
Yeah,
they can
okay.
go.
Hector, you got anything? Basida, have you got anything while we're
I got
waiting?
nothing. I was just listening to whatever homework helped, but
Me too.
That's cool.
I'll see you
You
on
too.
Tuesday.
Oh, you can hang about. You may have a good question you want to hear. Isabella, you got any question while we're waiting?
Yeah, I'm stuck on number 5 for 7.4.
Okay, can you tell me what question 5 is? What's it being asked to do?
Yeah, so evaluate the integral from 0 to 1 of x minus 4 over x squared minus 5x plus 6.
Okay, so we are looking at partial fractions, aren't we?
Yeah,
Did you notice that you can factor the bottom?
yeah,
So I'm assuming then that you did it correctly, and if you did, it was x minus 3, x minus 2. Did you
Yeah.
do? Okay, so what we're going to do now is just kind of, I don't know where you went wrong, so I guess I'm just going to do it until you say, that's where I went wrong. This is thankfully going to be quite quick. Would you agree that this one is 2 linears, so you just get an A and a B? And if you do the cover-up method, is very quick. So let's get this number A. Right, there's an x minus 3 here. So cover it up. And then what I do is I plug in 3. So what do I get? 3 take away 1 is negative 1 on the top. And 3 take away 2 is 1 on the bottom. So I get that. Which is what? Negative 1 over x minus 3. That's nice. Let's see what the second one is. Right. You want the x plus 2. So cover up that guy and plug in x equals 2. Let's see what we get when you do that. 2 take away 4 is negative 2 on the top. And 2 take away 1 is negative 1 on the bottom. And you get 2 of that. Did you get that?
Yeah.
Okay, so that's not a problem. So if we stick an integral around it, we got that. So what we're now going to do is negative the natural log of this plus 2 times the natural log of that, right?
Yeah.
Okay, so what we're looking at next is plugging in the 0 and the 1. Now, remember that the logs are not allowed to be negative, right? That's why WebAssign puts absolute values around some of them. I think that's might be where things are going to go wrong. So if you plug 1 in here, won't you get negative 2? Right, 1 subtract 3. Well, we don't do it. We imagine absolute value around it, so I get 2. Right, absolute value of negative 2, I got 2. If you go to the next one and you plug in 1, you get negative 1. So you're not allowed negative 1. You do the absolute value of it, you get 1. Take away. If you plug in 0, you get negative 3. So I'm going to call that 3. And you plug in 0, you get negative 2. I'm going to call that 2. So essentially, I just took the numbers that were inside the log, and if any of them happen to be negative, make them positive, and that's how you get round the heck up of not allowing negative values. Now, in this case, I still got some work to do. Negative log 2. What number is the log of 1? The natural log of 1.
0.
Right, so that basically doesn't matter then. Right? Take this away from that, you add a log 3. And then you're going to do what? 2 log 2s? Oh, take away 2 log 2s. So what's that going to get me? It's going to get me a log 3 subtract 3 log 2s. And that might well be, I hope it is, the answer that WebAssign wants, but they may take it a little bit further. Aren't 3 logs the same as the log of 2 cubed? Right,
Yeah.
multiples. Which means that you've now got 8. If you subtract 2 logs and you want to combine them into a single log, what's the process for doing that?
Divide the insides.
So it might be that WebAssign was looking for that.
Okay, I think it was that because I put in the first answer and it said it was wrong.
So it's just a matter of WebAssign being pernickety, although that is a very good answer, but not being generous about alternate answers. Because sometimes it's quite good, right? It'll allow 2 or 3 versions of the same right answer and it's happy. And other times it sounds like this is one of them. Nah, I only want this and only this. Right, Sean, have you figured out your guy?
Yeah. So it was problem 2 in 7.4. And it was one of the ones just like asking what the partial fraction would be. So
Okay,
it seems like easy, right? But then
tell me who the guy is and I'll tell you who he is.
it's number 2. But
What's the question,
so,
I mean?
It was asking what the partial fraction of, it was like x to the 4th and like a lot of other stuff over x squared minus 2x plus 1. And I was just wondering, the denominator has to be higher, right? Like
This has to be lower than this. If
the
it's higher, you
denominator
have
has
to
to
do a divide. That's maybe a problem.
Wait, say that again?
Right, I'll give you a different example. Suppose this was x squared plus 1,
Yeah,
and on the bottom you had an x plus 1, x minus 3, kind of look, right?
hmm
There would be a 1, and then you would have an a plus this, and then you would have a b plus that. And you might think, where on earth is that 1 coming from? If you take this guy and you look at this guy, can you remember doing long division in 141?
oh, yeah,
That's where the 1 came from. Now, if you had an x to the 4 on the top and stuff, right, then I strongly suspect you're going to have an x squared plus this. You know, if you do that into that. So it sounds to me that that's what the problem was.
okay, yeah, that's where I was going wrong, because I,
And if it's an x cubed at the bottom, you'd probably have an x there, right?
okay. So if I guess then the takeaway is like if the numerator is higher or equal to, then you have to do long division first.
Yes, but there aren't any questions after that where you actually get to do it,
Okay.
which kind of is nice. But if you had to do that, can you imagine how long these questions would be if you had to start off with a
Yeah.
long division before you could even do the partial fraction? So
Yeah.
I guess there's a reason why they didn't do it in the later questions because of that.